Hello everyone, I am Rahul Shandilya. In this uh, next lecture, we will discuss the number or system. So basically, we have been learning number system. The famous learning number system is decimal number system basically. So, but at the computer level, at the digital electronics level, the symbols are represented, as I told you, only two symbols, basically 1 and 0. So all our symbols, all our information symbols that we use in our practical life, in our daily life, have to be converted into 1-0 format, that is digital format. So we start with the converting number, basically decimal number, into binary numbers, because if we are able to convert number into binary numbers, we will let us see we can convert all our symbols into some kind of binary numbers. So let's start with first let's start with understanding of number system. What basically defined a number system? So the three basically important characteristics that define a number systems are the number of independent digits used to define number. So in a particular number system, basically we have some fixed number of independent digits. For example, in decimal, we use 10 kind of symbols: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And in binary, that will be used by our computer. Basically, we have only two symbols. The second important characteristics is the place value of a different digit constituting the number. Place value basically means 7, 9. So what is the place value of this? Is basically 9. And what is the place value of 7? It is basically 7 into 10 equal to 70. So this is basically 10 to power is the weight, and weight multiplied by the number at that position is the place value. So for example, in 759, basically what is the place value of this third digit? It is 7 multiplied into 10 to power 2. Here this it has weight 10 to power 0, it has weight 10 to power 1, it has weight 10 to power 2. So its place value basically is 700. So basically this defines place value. The second important characteristics of a number system is basically place value. And the third important, maximum number that can be written in a given number of digits. For example, we have say in decimal system two digit. We are using two digit to represent any number for in decimal system. So what is the maximum value? It will be 10 to power 2 minus 1. So because we are using two digits, so we have just give exponent to 2. So for n digit in decimal system, we have maximum number, that is here 10 to power 2 minus 1 is basically 99. So we know that if, with two digit our maximum digit is 99. So for n digit, basically the maximum number represented in decimal system is 10 to power n minus 1. Okay. So and the maximum number can be written. Now the important characteristic when you see the number of independent digits, basically we call it a radix. That is the important term, the most important terms for the defining a number system. Basically this radix define all this, even the second characteristic and third characteristic. So what is basically radix? Among the three characteristics and the most fundamental radix, it is known as the number of independent digits or symbols used, the number of independent digits or symbols used in the number system is basically radix. We also call it the base. Base and radix basically of number system is the same. So the decimal number system, as I have just discussed, we have radix is equal to 10 because we use 10 symbol 0, 1, 2, 3 to 9. Basically it is 10 symbols. And in the binary number system, that is the number system for our computer system, general digital computer system, is basically only two independent digits. Use 0 and 1. So here 0 basically is a symbol and 1 basically is a symbol used by a binary representation. So a binary number system is basically radix 2 or base 2 number system. So the radix of the number system also determine two characteristics. Yes, as I have told, the radix is the most important characteristics and basically determine all other two characteristics of number system. For example, the place value of a number digit can be basically given as say for example we have R0 position first digit, R1 position at the second digit, R3 position is equal to third digit in particular radix format. So in decimal system, for example, we have 789. So we have here R is equal to 10. So the width of this is 10 to power 0, and width of this is basically 10 to power 1, and width of this is basically 10 to power 10 to power 3. Now we can, the resultant value basically is written as 10 to power 0 into 9 plus 10 to power 1 into 8 and plus 10 to power 3 into 7 is equal to 789. So in this way we see the place value is basically defined by radix. R is equal to 10. This width is defined by radix. Similarly, for a binary number, for example, we have 101. So here for binary number, R is equal to 2. So what will be the place value? 1 into 2 to power 0 plus 2 to power 1 into 0 plus 2 to power 2 into 1. This 1 is basically the number at particular digit. So this is in binary, in decimal equivalent it is say 1 plus 4, 1 plus 4, so it is basically 5. So this binary number 101 is basically 5 in our decimal system. Next is the fractional. This was the integer part. I have shown integer. Similarly, in the fractional part, basically, for example, we have 10.25. So the place value of fractional part is given in terms of weight 10 to power minus 1 into 2 plus 10 to power minus 2 into say 5 is equal to 0.25. So this is the fractional part. Again we see here it is R2 power minus 1 and here it is R2 power minus 2. So this weight is again defined by the radix. Similarly, in binary we have, say for example 10.01. So what is this place value? Its place value for fractional part is basically 0 into 2 to power minus 1 plus 1 into 2 to power minus 2. So basically it is 1 upon 4. In decimal equivalent of this is basically 0.25. So we see that the weight in the number system, the weight is basically defined by the radix, and thus the place value is determined by the radix. And also the maximum number in a decimal number system, the maximum number in a decimal system is also defined by the radix. For example, in say decimal number we have radix is equal to 10. So what will be the maximum number defined by n digit? So it is basically 10 to power n minus 1. That is the maximum number defined in a particular number system if we have radix. R is basically R to power n minus 1, where n is the number of digit used to represent number. For example, in binary number system, if we have 4 digit, so the maximum number defined by the binary number, that is 1111, is basically 2 to power we have four digit 1 2 3 4, 2 to power 4 minus 1, that is 15. So with four digit of in a binary number system, the maximum number is 15. So we have, based on the radix, we have some popular number system used in the digital electronics. Basically, the most important we have is the decimal number system. It forms the reference number system. We have already said that the decimal number system used 10 symbol, 0 to 9, and thus radix is 10. And for example, 734 is represented like this. I have already explained on the first position. On this basically 4 is also known as most significant digit in a decimal number system, and this 7, this last digit, is least significant digit. So the most significant digit has bit value say 10 to power 4, next digit has bit value 10 to power 1, and so on. So this is basically a decimal number system. And here, for example, the I told you this 4 is basically least significant digit, and this 7 is basically most significant. Similarly, here 5 is basically least significant digit, and this 1 is basically most significant digit. And the weight value, as I've told, it is 5 have 10 to power 0, and 1 has basically 10 to power 4 because it is at 5th position. So next popular means the most important for computer is basically this decimal number system is for of reference purpose. Basically we are converting our symbol that we use in practical life, that we use in daily life, into some binary number. So basically from decimal number we are defining what are the characteristics of number, how a number system is basically defined, and we use the same method to define the binary numbers. So binary numbers is based on two level logic, conventionally noted as 0. Low level means a 0 basically represented by lower voltage, although it is not always true. Basically we have used positive low level logic and high level logic. So for example, in most of the circuit, 1 is represented by high level, basically high level voltage, and we use only two symbols, therefore radix is 2. So for example, we have decimal number 13. What will be its binary equivalent? So we have decimal number 13. So what will be its binary equivalent? Basically binary equivalent, writing binary equivalent means writing this number, writing 13 in terms of only two symbols, 1 and 0. So as we know, the first the decimal number system, binary number system weight is 2 to power 0, 2 to power 1, 2 to power 2, and 2 to power 3. So basically it is 1. Always remember this. It is 2, and it is 4, and it is 8. Now say 13 is equal to, we can write 13 as 8 plus 4 and plus 1. So 1 we put here 1, okay, and so for the fourth term say we put here 1 again, and the 8th term we put here 1, and all other place say here we do not have a 2, so we put here 2, and say, so this is the number is basically 1102. And similarly 1 to 5 can be written as in a decimal value. Say for example we have here similarly this number is represented as, for example, 1 to 5 is basically 2 to power 0. Here we have 16, 32, and 64. So basically 1 to 5 represented as 64 plus, we see here 1, 32 plus here is again 1, so it is, here is again 16, and plus here is again we have 8 here, 8 plus here it is 0, so we will not count it. Here it is again 1, so it is equal to 1 to 5. In this way we represent binary numbers. There are other two numbers that are basically used to define, say, represent a binary number as a collection of 3 or collection of 4 binary numbers. So we have this octal number. Based on same procedure, we can define two other more important that is used in our number system is octal number system. So octal number system basically use 8 symbol 0 to 7. So there will be no 9, no 8 in octal number system. Always remember. All others decimal place symbols is used, but there will be no 8 and no 9 in octal number system. For example, 250. So basically radix is equal to 8. So basically the weight is given in terms of the power of 8. So 8 to power 0, it has weight 1. 8 to power 1 at the second digit, it has weight 8, and 8 to power 2, basically it has weight 64. So now let's see 250. How in the decimal number, how we can represent 250? So 250 can be written as sum of say 64 plus 264 is 64 into 3 plus basically 7 into 8 and plus basically 2 into 1. So basically this way we can represent 77 into this form, decimal form. So how we find basically this 372, there is a good procedure by continuous division that we will discuss later on. But we can see that 250 and 277 in decimal number can be expanded like this in octal number system. Similarly, we have hexadecimal number system. So basically octal number system maximum number is 7. Sorry, symbol is 7, 0 to 7, and maximum number system is basically 2 to power 8 symbol, 2 to power 8 minus 1. In hexadecimal number system, we use 16 symbol. We use 16 symbol. So it is a radix 16 number system. Now, octal number system we use less than 10 symbol basically, and on hexadecimal we use more than 10 number system. So a decimal number system can be represented lesser number of symbols in hexadecimal numbers. Basically both of these numbers are used to represent binary number system. For example, that we will convert see later. Now say 291 can be written in hexadecimal in a similar manner. Here the weight is in terms of 16 to power 0, 16 to power 1 and 16 to power 2. Now basically we can see that 291 can be written as sum of 3 into 1, 3 into 1 plus 2 into 16 and 1 into 16 to a square. So the resulting number is basically 1, 2, 3 subscript 0. We write always this subscript because in 1, 2, 3 in octal number system has a different decimal value. 1, 2, 3, if we write 1, 2, 3 here in octal, it has a different decimal value, and if you write here 16 subscript, it will have a different decimal value. So it is important, always important to write subscript, radix subscript in a number system. If you are by default, if there is nothing by default, we can assume it is a decimal number system. If it use terms like 7, 8, 9, and if it only use 1, 0, 1, 0, 1, we can by default say that it is a binary number. And for octal and hexadecimal number, we always use subscript. Even to describe binary also we use subscript, and whenever we use multiple number system, we always use this subscript notation to represent a number system. uh, so basically you should memorize 1 to 16 decimal equivalent in binary, octal and hexadecimal. If for example we have 1 2 3 4 5 6 7 8 9 10 11 12, these are binary numbers, so its binary equivalent is basically 0. We are representing 4 numbers because hexadecimal need 4 binary number to represent. Okay, so its number is 14, so here 0 0 0, and the octal equivalent is again 0 0 0 also. And say for example number is 5, its binary equivalent is 0 1 0 1, octal equivalent will be basically 5 only in octal representation. Basically it is 5 only. Say for example here we have 7, its binary equivalent is 1 1 1, octal representation is basically 7, and also the hexadecimal is also 7. Now see here for example 9 are basically more definite. Now see for example 10, the 10 representation of say in binary is basically 1 0 1 0, and its octal representation is basically say 8 plus 2. So basically it will be multiplied by 1 into 8 to power 1 plus 2 into 8 to power 0. So basically 1 and 2. So 1 and 2 will be its octal representation, and its hexadecimal in 10 is basically A, and in hexadecimal basically 11 is basically B, and so on. So 15 hexadecimal is equivalent to say F 16, and 15 binary equivalent is basically 1 1 1. So you should make this table and always remember 1 to 16 binary, hexadecimal and octal representation. This is the end of the lecture. We will continue this same number system conversion and some operation on number system in next sub part of this